Okay, I'd like to just give you a quick review over some of the things we've done for tomorrow. Remember, we would solve problems with like bases. This is one technique to solve for this exponent. I've got 8 to the 3x plus 2, and I've got 16 to the 2x minus 3. We want to solve for our variable x, and it's in the exponent. Okay, one way is to look at these numbers and realize that there's a number, a like base. I have a common base, like the base of 2, to a certain exponent, and we can write both these as base 2. 8 is 2 to the third power. So notice how I rewrite 8 as 2 to the third power to the 3x plus 2, and 16 is 2 to the fourth. So you should be able to figure this out. You should have a good knowledge of this, or at least a way to figure out. Okay? So notice I put this in parentheses, 2 to the third to this power, and this is 2 to the fourth to this power. Remember, when we have an exponent, when we raise a power to a power, we multiply. So 3 times 3x plus 2 is 9x plus 6. 4 times 2x minus 3, 2 to the fourth to this power, we multiply the exponents, that's 8x minus 12. So basically, hey, I've got, what I didn't really write down here was, let me rewrite this. I've got okay. Basically, I've got, notice how I've got common bases. I've got this right here becomes that, 2 to the 9x plus 6, and this right here becomes this, 2 to the 8x minus 12. So now this base to an exponent equals this base to an exponent. So basically this equals this. So now we just set what? You know, these obviously, if 2 to this power equals 2 to this power, obviously the exponents have to be equal to each other. 9x plus 6 equals 8x minus 12, and the rest is algebra 1. I subtract 8x from both sides and get x, and then I've got this, I take minus 6 from both sides and I get negative, this is gone, and I get this right here, x equals negative 18. Negative 12 and negative 6 is negative 18. Okay? Alright, we have another type problem. Okay, here's your basic solving for an exponent, okay? Alright, this is base 7 to an exponent of x equals 9. Notice how I take the log, and this is what we always want our exponential functions. Strip down just a base exponent, what it equals. I took the natural log of both sides. That allows this exponent to be rewritten in the front like a factor. So it's x times log of 7 equals log of 9. So I divided both sides. I get rid of this multiplication with division. I divide both sides by log of 7. X equals log of 9 over log of 7. And that's a calculator exercise. You come up with a number, okay? Here's another exponential function, but we need to clean it up first. I've got 3, my base is e, which is 2.718 ... 3 times e to this exponent plus 3 equals 65, and we've worked this one. I want to strip away everything so it's just like this, base to exponent equals the number, okay? So first thing we do is we handle addition and subtraction. We do reverse PEMDAS, add and subtract first, then multiply, divide, so on. So I subtract 3 from both sides, and then I've got 3e to this exponent equals 62, and then I get rid of this 3 times e by dividing, and that cancels out, and I get e to the negative 3x minus 4 equals this right here. Okay? So e to the negative 3x minus 4 equals 62 over 3. I take the natural log of both sides. And you could take the common log, but you don't really want to when you're dealing with e. Alright? So that allows what? This exponent moves down here. Negative 3x minus 4, and that's kind of like this factor here. Alright, times the natural log of e, which is 1. That goes to 1, okay? E to the first power gets me e, okay? And that equals, notice we took the natural log of both sides, right? We took the natural log here and the natural log here. This comes down in front. Log of e is 1. That's very convenient. Equals the log of 62 over 3. Okay? Alright, and now this is going to, notice how I put that in parentheses, log is 62 over 3. Alright, we've got to solve for x. So I've got negative 3x minus 4 equals this natural log of 62 over 3. Notice what I did. I added 4 here and add 4. Okay, so negative 3x equals log of 62 over 3, and that's a number, plus 4. And then I need to get rid of this multiplication. Notice I take negative 3x and I divide by negative 3, and then I'm left with x. And I notice I divide this whole thing by negative 3, okay? Alright, so when you get this, you just add 4 to both sides, divide by both sides by negative 3, and here's your answer. This x equals all this right here. Log is 62 over 3, plus 4, and that entirety, this whole thing, divided by negative 3. Alright? 5 minutes. See, I'm doing pretty good. Alright, here is, I've got log on both sides, and I basically want to get log equals log. We have the tougher one with quadratics, but this is, we're going to want to, on one side, what we have here is log of x minus log of 6. I've got individual logs with the same base as base 10, and I can rewrite this expanded form of log of x minus log of 6 as basically a single log reflecting division. Division with common bases, we subtract the exponent. So I rewrite this as log of, here's my dividend and here's my divisor, log of x over 6. Notice it's a single log, log of x over 6. Equals log of 3, and I've got log on both sides. Log equals log. When you have this situation, this equals this, okay? So x over 6 equals 3. If this log of this equals log of that, then this equals this. Okay, so x over 6 equals 3, and you just multiply both sides by 6. And that cancels out, and 3 times 6 is 18. Times 6, and that's what you get, okay? So x equals 18. So when you've got log on both sides, simplify to get a single log equals a single log. Remember, if this was addition, it'd be x times 6, okay? Right here, all right? Okay, I think we have one more. Okay, this I've got. Now notice this is a little different. I'm trying to cover everything efficiently. Here we've got, the big thing here was log on both sides, okay? So we get a log equals log. This next one, we're going to still want to simplify, but notice I don't have the log on the right, okay? That's where you're going to, okay, so I've got log of 3x plus 9 plus log of 5 equals 4. This side here I'm going to simplify, rewrite addition of individual logs as multiplication of, this would be a single log of multiplication of, this would be a factor, and 3x plus 9 and 5 would be a factor. Okay, so remember when we multiply common bases, the exponents we're going to add. So this is an exponent here. So, all right. So log of 3x plus 9 plus log of 5 is rewritten as a single log of 5 times 3x plus 9 equals 4. Okay, so notice it's only a log on one side. So here we've got all the components we need. I've got log, I've got a base, right? And an exponent, and so I've got e to the 4th equals this. So when you have this log on one side, make sure you clean it up just to get log of something, okay? So basically I have what? E to the 4th power equals this right here, which is 15x times 9. This is a little more just stuff involved, just multiplication. So, but when you've got log on one side, simplify it to a single log, okay? You know your base here is e. So you've got base, exponent, e to the 4th equals this right here, okay? All right? And this right here, notice what I did here. This was 5 times 3x is 15x, 5 times plus 9 is 45, okay? All right, so base to exponent equals, all right, this is a number. This is something, this is done. This is not the e is not a variable. It's a, okay? E is not a variable. It's like pi. It's a constant, okay? So that's a number, and we just want to solve for x. So notice I'll minus 45, which is what I have here, and then we're down to this, and we divide by 15, and notice I divided everything, this whole thing by 15. So x equals, so I took this right here, I minus 45, and then divide everything by 15. Okay, so that's what x is going to equal. Okay, so recap that one real quick. All right, I simplified this addition into a single log. I simplified this part into 15x plus 45. But when I get a log equals something, I've got a base, exponent, e to the fourth, that's a number, equals 15x plus 45. So we got to strip it down to solve for x. So I do addition and subtraction first. I subtracted 45, minus 45. That's gone. And then I've got to get rid of this 15.
All right, Southwest.
Okay, sorry, I had a pause. I got interrupted. So again, we're solving for x. I minus 45 and then divide by 15. So hopefully you all follow that, okay? So I've got my base exponent, that's a number, okay? Those are the type of problems you can have, okay? Hopefully I clarified that. Sorry, I had an announcement that I had to pause the recording for. I wanted to, and I got kind of distracted. So hopefully everyone can do the math here. But just minus 45, divide everything by 15, and you get x, okay? I know I'm being repetitive, but I'm not sure where I left off after pausing, okay? All right, I'm going to make another video for tomorrow's lesson. This is for a quiz test review, okay? All right, see you tomorrow.